Alright guys, I'm going to pick it up at number 10 here. Most people got through number 9 in class today, and I'll go ahead and do some sample problems for 10 through the rest of the multiple choice, and then I'll also do some for the free responses as well. So let's begin here. So on number 10, you're going to have a question that looks like this. That's supposed to say G. And we want to find the derivative at -2. So this is going to be the quotient rule. So it's low D high minus high D low. Draw a line and square below. Now you can simplify first if you want to, or you could just plug the number in now. I'm going to go ahead and just plug the number in now. So if we plug in -2, I get 4 plus 3, which is 7. Plugging it in here, I get -8 minus 5, which is -13. Plugging it in here, I get -6. And then plugging it in there, we get 4 plus 3, which is 7. Oh, and that was supposed to be squared, by the way. And then we're just going to simplify. So this is 28. And it's going to be minus 60 and 8 is 78 over 49. And that's -50 over 49. And that can't be reduced, so that would be my final answer there. Okay, so quotient rule, plug it in, not too shabby. Let's go ahead and take a look at number 11. So we have find h prime of 2 if h is equal to this. They give us a graph of f and a graph of g. So first thing we want to do is we want to find h prime. H prime is going to be the quotient rule. So it's going to be low D high minus high D low. Draw a line, square below. Okay, so there's our derivative, and now we want to plug in a 2. So let's see what that'll come out to be. We have h prime is going to be equal to g of, I'm just going to go ahead and write it on top here. We're going to plug in a 2. So now if I want to find that g of 2, that means I'm looking for the y value on the g function when x equals 2. X equals 2 right here, and the y value is 5. So this is 5. Plus, we're also going to plug the 2 in here. That would be 4. Then we have 2 times f prime. F prime, that's the slope of my f function. We want to find where the f function has an x value of 2. That would be right here. And that means we want to know what the slope of this line that we're on there. The rise is -2 and the run is 1. So the slope would be -2. Then we have 2 times, plugging in 2 here, what would f of 2 equal? That's the y value at that point, which is -1. Then we're going to plug 2 in here. But for g prime of 2, that's the slope at this point on the g function. So that's a run of 1 and a rise of 2, so +2. Plugging the 2 in there, the same thing we had earlier. It was going to be the y value on the g function when x equals 2, and that is 5. Plus, plugging 2 in here, 2 times 2 is 4 squared. And then we just get to simplify the whole thing. So the big thing you guys need to know here is, first of all, you need to know your quotient rule. Second of all, you need to understand that when you are finding like g of 2, that means the y value. But if you're looking for g prime of 2, that means the slope. Same thing with the f function. So let's continue. So that's 9, -4, -5, 4. The bottom's 81. And so that would be negative 36 plus 20 over 81. And that's going to simplify to negative 16 over 81. And I don't think that reduces, so I'm all done. But the last part's not all that amazing. It's just simplifying. But the big steps are knowing how to do the quotient rule, of course, and also knowing how to evaluate the functions and their derivatives using the graphs. All right, let's go ahead and move on to question number 12, I think. Actually, I ended up deciding just to have you guys go ahead and skip question 12, so don't worry about that one. And as for questions 13 and 14, they're pretty straightforward. I would say just look at your rules for the derivatives of trig functions, and that's how you'll handle those. All right, so we'll go ahead and move on to the FRQs next. Okay, so we're going to look at two FRQs, Part A and Part B. So let's look at Part A. On Part A, you're going to be given a graph as well as a couple of functions here. Let me adjust my screen so you can see it. And then basically after that, we're just going to be asked to find some derivatives. So let's go ahead and do that. So my first thing is I'm given this function, and I'm being asked to find m prime of 2. That's going to be a product rule. So according to the product rule, we're going to have bx, j of x, b of x, j of x, and we'll do prime on the b for this set and prime on the j for that set. And then we're going to go ahead and plug in the 2. All right. So remember that these are slopes. Those are slopes. These are y values. Okay, so here we go. Let's begin. So first of all, let's do the b. B prime of 2. So we want the slope at x equals 2. So here's where x equals 2. And that slope is down 2 over 1. And so rise over 1 would be negative 2. So that's equal to negative 2. J of 2, that would be this function right here. So I need to plug 2 into that function. So let's do that. If I plug in 2 here, I get 4. If I plug in 2 here, I get 8. And then plus 5. All right. Continue. B of 2, that's the y value on my graph of b at x equals 2. And so that y value at that point is negative 1. And we also need to find j prime of 2. Now that's going to take a little bit of work because I need to find this derivative first, and then I'm going to plug in 2, right? So let's see. Now I notice a lot of you guys like to do the process where you rewrite it like this. And I think that's fine. But we do have a nice little shortcut rule for derivatives of square roots. Anytime you want to take the derivative of a square root function of some kind, right? It always ends up being 1 over 2 times the square root of that value times the derivative of whatever's under the root. So that's our little shortcut rule. We do have a nice shortcut derivative rule for square roots. And I actually prefer that one. So although I see a lot of you guys doing this, and I think that's a good method to know because if you have a cube root or something, it's handy. But, you know, when it comes to square roots, I would say use the shortcut. And so the derivative of this using the shortcut would be 1 over 2, and then just the square root as it appears, multiplied by the derivative of the inside there. And there's my derivative. Okay, now if I want to find j prime of 2, which is what I'm trying to find right now, I need to plug in 2 to this thing. So let's do that. 1 over 2 times the square root of 4 minus 8 plus 5 times 2 times 2 minus 4. All right, so I have 1 over 2. This is going to all equal 1, and the square root of 1 is 1, so we just have times 1. And this is 0. And anything times 0 equals 0, so this ends up just being 0. All right, so let's review. We have our function. We found the derivative using the product rule. We plugged in 2. For the graph, the derivative means slope. The non-derivative means the y value. And then for the square root function, when we had the derivative, we had to do the formula. All right, now we're ready to continue. 0 times negative 1 is just 0, so we can ignore that. And this just gives me 1, so we have the final answer is negative 2. All right. Let's go ahead and take a look at question 1b. Same given information, different function here. So now I'm telling you that m is equal to b over 5 times j. So we're going to use the quotient rule. Low, d high, minus high, d low, draw a line, square below. Okay, now we're going to go ahead and be plugging 2 into all these places where there's an x. All right. So what is j of 2? Well, we plugged that in already. On our last problem, we saw that we did j of 2. That means we plug it into this function here. We ended up with 1 as a result. And we also found j prime of 2. J prime of 2 turned out to be 0. So if you want to see how we got that, look, rewind to question 1a and you'll see how we got j prime of 2. All right. So let's go ahead and begin here. So we have 5 times j of 2. J of 2 is 1. Times b prime of 2. That would be the slope of the b function at that point, which we said earlier was negative 2. Times b of 2, which is the y value at that same point, which is negative 1, times 5 times j prime of 2, which is 0. So once again, we just get to use a lot of those same numbers all over again. J of 2 was 1. I forgot to have a square there. All right. So this whole piece here just goes away because we're multiplying by 0. This piece here is negative 10. And on the bottom here we have 25. And of course we want to reduce if possible. We get negative 2/5. All right. 1c we're going to skip. So let's move away from that and move into our second FRQ. FRQ part B. I believe there's 2 parts to this FRQ, but we're only going to do 1A through D today, so we'll stop at that point. All right, so in this one, looks like they're giving us 2 graphs. One is the graph of f, and the other one is the derivative of f. So we've got 2 functions up there, a function and its derivative. Question 1A is asking us to find the average rate of change of f. Find the average rate of change of f. This is our average rate of change formula. And it looks like we're going from negative 3 to 3, so that would be looking like this. So there's my average rate of change of f. Then it says, for how many values of x in the interval from negative 3 to 3 does the instantaneous rate of change of f equal the average rate of change of f on that interval? So we really have 2 questions in this question. We have find the average rate of change of f, and then we also want to know how many times does the instantaneous rate equal the average rate. All right, let's go ahead and find the average rate first. F of 3, that's the y value when x equals 3 on the f graph. So I'll say that again. We're looking for the y value when x equals 3 on the f graph. So here's where x equals 3 on the f graph, and the y value is negative 3. So we have negative 3 minus. Now let's find f of negative 3. F of negative 3, that would be here, and so the y value at that point is 1. And on the bottom we have double negatives to make a positive, and that would be negative 4 over 6, which you could reduce to negative 2/3. Okay, so there's that. Now the next thing they want to know is how many values of x on that interval does the instantaneous rate of change equal the average rate of change? So if you guys look at your notes from this weekend, if I'm asking you how many times does the instantaneous rate equal the average rate, what I'm really asking you to find is, when you're looking at a graph, how many places did the tangent line parallel to the secant line? I could see where there might be like 2 places where that happened. Like maybe one would be like kind of close to here, and probably one down here also. And so to me, it looks like there would be 2 places where the tangent line could be parallel to the secant line. All right. Now, another way you could do this, although it's a little bit different, is you could actually just graph this number, negative 2/3, which is about right about here. Just draw a horizontal line, negative 2/3, and see how many times does your derivative intersect that, because this is the derivative graph. It also equals 2. So there it is. And so my first answer is this, and my second answer is the instantaneous rate is equal to 2/3, negative 2/3, right? Twice. All right. Let's move along. Question 1b. Find the equation of the line that is tangent to the graph of f at x equals 3. So when you're looking for a tangent line, you need 3 things. You need an x value, you need a y value, and you need a slope. The x value is given as 3, and so that's this point right there, which means that the y value is negative 3. And so now we just need the slope at that point. Now, how can we find the slope at that point? Well, the slope is whatever the derivative is at that value of x. So now I'm going to look at this graph, and I'm going to find where x equals 3 on this graph, and that's right there. And the slope is that height there, it's 4. So f prime of 3 is equal to 4. So that's different. So let's review. If you want to find the y value of the graph of f, you just find that point on the graph and look at the y value. But if you want to find the slope of f, then you look at the f prime graph and find the y value on that graph. So the y values on this graph are the slopes of that graph. Okay? All right, so now we're ready to go ahead and write out our tangent line. So it's y equals the slope times x minus 3, and we're all done. You could stop right there. Moving along, let's take a look at 1c. For each of these, we want to find the value or state why it doesn't exist. All right. Well, first thing we got to notice is this is not just any old limit. That is the limit of a difference quotient, which means that this represents a derivative. Okay? This is the alternate form for the limit definition of a derivative. I'll write it up here for you guys. When you have a limit that looks like this, that actually represents the derivative of this function at this number. So what this actually represents, I'll write it out. What this actually represents is the derivative of that function at 0. Likewise, what this actually represents is the derivative of this function at negative 1. So basically, I need to find what's f prime of 0 and what's f prime of negative 1. So for that, let's go ahead and take a look at our f prime graph. What is f prime of 0? It's right about here, and so I would speculate that that value is about 1. And what is f prime of negative 1? Does not exist. Okay? Now, why doesn't it exist? Well, there's a few ways that we could say that. Now, I think it's easiest to understand why this derivative doesn't exist when we look at the graph of f. But we also have to remember that if we're talking about f prime, we're talking about the slope of f. So why does the slope of f not exist here? That's a cusp, okay? So what's going to be a good explanation for that? Well, if you look at our notes from over the weekend, whenever you have a cusp, the derivative doesn't exist because the limit as x approaches that value for the derivative from the left is not equal to the value of the limit as x approaches that value of the derivative from the right. Okay? So that's our reason why this one does not exist. So you have that and you have that. And just so you guys know, how would they be grading these? I haven't been talking a lot about how you'll be grading on these, but you understand that FRQs, how you show your work, is important. I would say that they would probably end up making this question 3 points. Like this is 1 point for getting that derivative value. This is 1 point for getting that fact. And this is 1 point for stating your reason. That would be my guess about how they would split the points up here. Okay? All right. Let's go ahead and move on to question 1. I think it's supposed to say 1D at this point. All right, so here we go. So if j equals this, find j prime of 1. So j prime is first. So that's going to be another product rule. So we have the derivative of this multiplied by this plus this multiplied by the derivative of that. And we want to plug in 1. Okay, so let's simplify what we can here first. This is 4. That's 2. And this is the y value of the f function at x equals 1. So the y value at that point is 1. Now this is the slope of the f function at x equals 1. But the problem is this is a curving line, so we can't really say what the slope is because it's not a constant rise over run, so you can't just calculate the slope that way. So instead, we're going to look at the f prime graph to figure out what this is. So let's look at the f prime graph and find where x equals 1. That's right here. And according to that, our slope would be negative 4. Okay, so I have 4 minus 8 equals negative 4, and that's the end of that one. And that'll do it for today, guys. So hopefully that was helpful. We'll see you guys in class tomorrow. Till then, have a good one.